Turn the board on, that would help.
Would you make on the SAP?
Oh, that's not what I want. My camera. Why is it not doing? There we go. Okay. All right, guys. So this is the last lesson of the book. Hey, what are you cheer?
I was.
All right, so we're still talking about matrices, and we are still going to talk about solving systems of equations today, but I'm going to give you a fifth method to use.
Yes.
So one method, graphing. 2, substitution. 3, elimination. 4, I'm running out of room. Kramer's rule. And 5, inverse matrices. Who knew there were so many ways? Okay, so inverse matrices will kind of work like this. If we have an equation 3x equals 15, we divide by 3, correct? To solve for x. Couldn't we also get the same result if we multiplied by the reciprocal? Okay, so 1/3 times 3 is 1, 5 times 1/3 is 5. So it gets the same result. So basically what we're going to do to solve an equation with matrix inverses is we're going to multiply by the reciprocal, which is what we call the multiplicative identity, which was the inverse that we were finding the other day. And when we were finding like A inverse, that was like the multiplicative reciprocal. Because when we multiplied by it, we got the 1, 0, 0, 1. Okay, so this is the whole concept that we're going to use, which really equates to doing something like this with real numbers. Okay. A system of linear equations can be written as a matrix equation. Just look at this and see if you can tell me what's going on. Regular system of equations, matrix equation. Okay, so where did this first one come from? All the coefficients. Where did this one come from? The variables. And what is this one? The constants. Okay, so would that times that give me that? Well, they're the right dimensions. Think about if I went across and down. I would have A times X plus B times Y. Well, there's AX plus BY. If I did the second row of the column, I would have C times X plus D times Y. There's CX plus DY. So yes, those are the same. Okay, if A equals this, and X equals this, and B equals this, then what I'm basically saying is A times X equals B. Therefore, what if I had this equation, AX equals B? How would I solve for X? Just AX equals B. How would I solve for X? Everyone's looking at title. Divide by A. Or multiply by what? Okay, the inverse of A, right? Right, so what I'm going to do is say that X equals A inverse times B. So multiply both sides by A inverse gets me this. So this is how we're going to solve systems of equations today. All right, so let's take an example down here and I'll walk you through it step by step. First thing I'm going to do, just like we've been doing, make sure the x's are lined up, the y's, the equals, the constants, and then I'm going to convert it into an equation like this. Okay, so my first matrix will consist of just coefficients times x, y, the variables, equals -14, -25, which is the constants. So I just translate that normal set of equations into this matrix equation. Could I put this matrix x and then y next to it? This is a 2 by 2. This is a 2 by 1. If I switched that around and made it like that, then it wouldn't be compatible. Because remember, the 2 in the middle have to be the same. So it has to be written vertically like that, or else they can't be multiplied. And then same with these two. Okay, so that's my first step. The next step is to figure out what the inverse of this is. Because this is my A, and I need to know what A inverse is. Okay, so let me put underneath here. I'm going to say this is A times B. And I'm going to just use C over here. Switching up my letters, so maybe you start doing. Okay, I want to find A inverse. How can I find A inverse? I have two ways.
C equals A inverse B.
Okay, but how can I find A inverse? If I need to know what A inverse is, I can either do it by hand, which is first of all find the determinant, then put 1 over the determinant and do the little switcheroo thing. Or can I use my calculator? Yep, let's do that. Okay, so what I'm going to do is label this as A in my matrix menu. So go over and edit A. It's a 2 by 2, 7, 5, -6, 1. Okay, and I want the inverse of it. So I'm going to quit, go back to matrix A inverse. Now, if I get decimals, which I did, those are messy decimals, so I'm going to go to math, fraction, enter, and then it turns it into some fractions for me. Okay? All right, so let's write this down. A inverse is 1 over 37, beautiful fractions here, 6 over 37, -5 over 37, and 7 over 37. Okay, so if I multiply both sides by A inverse, so if I put over here A inverse, what is A inverse times A? 1001?
Yeah.
Right? A inverse times A will give me 1001. Okay, so it's essentially, go back up to this little equation, it's essentially getting rid of that coefficient is what I'm doing. So I'm basically getting rid of that matrix by multiplying the left by the inverse. Can I multiply on the right by this 2 by 2? What are the dimensions of this one? 2 by 1. Can I multiply by 2 by 2 over here?
No.
No. What about if I put it there? Then I can do it. Okay, so where I place it matters. So what I'm going to do is plug it in right there and multiply, and then I'm going to plug it in right there and multiply. Because I technically can't multiply it on the right, dimensions won't be compatible. So I'm going to say, all right, I'm going to take this inverse, multiply both sides of the equation by it. Those cancel out and give me 1001 times xy. And then I'm going to multiply A inverse, I've called that C, so I'm going to say A inverse times C. And then this is just like a 1 sitting there. So my answer that I get over here will tell me what x and y equal. Okay, so how do I do this on the calculator? Let's put C in, and I'm going to call it C in my calculator just because I did on the paper. It can be B or whatever. Don't use A because we need A. Go back to your matrix, edit. Again, I'm just going to call this one C because I did on my paper. And C was a 2 by 1, negative 14, negative 25. Okay, quit. All right, so what I want to do is multiply A inverse times C. Now, I already have it on the screen, but I'm just going to reset it up. I'm going to say matrix A inverse times matrix C. And I get the answer 3, negative 7. So guess what X is? 3. Y is negative 7.
Oh,
So the ordered pair is 3, comma, negative 7.
but this B,
B is just my variables. So it's like a filler for the variables because you're solving for the variables. You can't make them go away. So this is like 1 times X is 1 plus 0 times Y is 0. So this says X equals 3. Okay. So that this one has always got to be there, but you're not typing that in the calculator in any way, shape, or form. Okay. All right. So I did a lot of explaining on this one. We can kind of jump to a shortcut without all the explanation because this is basically what we need right here. The inverse of these times the constants. Okay, so I can just drop down here and say, I'm going to set up my equation first. 12, 11, negative 8, negative 5 times xy equals negative 35, 21. Okay, so I'm going to say that xy equals, I'll label these with an A and a B. If you just want to use B, we can use that. That's A and that's B. Then xy will be A inverse times B. Now I've got to type A and B in my calculator, but the rest can be done totally on the calculator. And I have a question of what I wrote down. Okay, so let's plug these in. Matrix, edit A, say 2 by 2. Then I'm going to go back to matrix, edit B. It is a 2 by 1. And once I have those two matrices in my calculator, I need literally what I have written down here. Matrix A inverse times matrix B. And those are my answers for X1. Questions?
so that's
Okay, so I would say xy equals negative 2, negative 1, therefore negative 2, comma, negative 1 is my point of intersection of those two lines. Find the same result by graphing, by elimination, by substitution, by Cramer's rule. All right, let's do a 3 by 3. You think this is going to be easier? Yeah. Okay, so let's set up the equation first. The equation will be all the coefficients times all the variables equals all the constants. Okay, so if I call this A times the variables equals B. Basically, what I want to do is get rid of this. I want to divide by that. Well, dividing by it is really multiplying by the inverse. So I'm going to multiply both sides by A inverse. So it's like putting A inverse over here, but I've got to put A inverse on that side, otherwise it's not compatible. That just changes it to all the ones and zeros. So basically gets rid of it for all practical purposes. And I'm left with that product. And if I do that on my calculator, it will give me X, Y, and Z. That's much quicker than the substitution elimination, isn't it? Matrix edits. Those of you not typing this in, you're good. You know how to do this. Y'all good? You know how to do it. Okay, so that's A. Go back, edit, edit B. It is a 3 by 1. Okay, and I'm going to do matrix A inverse times matrix B. There's my X, Y, and Z. So -5, 2, 8. My solutions. What do you think? Like it?
I got a decimal in mine.
Then my guess is some little pesky number in your matrices was typed in wrong. So I'd go back and proof those matrices and see if you probably missed a negative on something. Okay, all right. I want you to do this one. And if we can do it well and have no issues, then I'll go ahead and give you that take-home test. Okay?
I didn't.
You didn't type. Okay, let me look. Let me pause this. On sharing your work. Okay, so John's hand first. Borrow this tray for me. You're still working.
I know.
All right.
I'm going 1 pound.
Hey, what do you think? Did you get the same thing?
Yeah, but they're
Any questions? Okay, so think about all the methods that we've used. If you had a 2 by 2 system, raise your hand if you would prefer graphic. Substitution. Where are my diehard substitution people? Elimination. Okay, a Kramer's rule with the determinants yesterday, 2 by 2 over 2 by 2. This, oh my gosh. Okay, now a 3 by 3. Who would prefer algebra? I kind of like that. I think it's kind of fun.
You enjoyed that.
Coach Harper thinks I'm crazy. We had a debate yesterday over which method we would use on a 3 by 3, and I just kind of like the algebra.
What did he say?
He likes this method. And I kind of like Kramer's rule too. I don't know why, but yeah, this one is easy. You're right. Okay, so 3 by 3. This is probably the safest way not to make a mistake. Because with algebra, we tend to miss so many things. Okay, that's it for the last lesson. Should we have a round of applause? Good job, everybody.
Honestly, it was